Well, good afternoon. We are on section 4.1, prime factors. So we're going to start out. What I want you to do is go ahead and hit pause and copy down this information. So go ahead and do that. All right, so now it says factor. That is two or more numbers that multiply together to give you a product. Okay, that number, the answer to that. For example, 2 times 3 equals 6. The factors of 6 are 2 and 3. Okay. There's also two other factors of 6, which would be 1 times itself, also equals 6. So my factors for 6 are 1, 2, 3, and 6. All of these numbers that are underlined. Okay, those are factors. Prime, again, is a whole number that has exactly two factors, 1 and itself. So for example, the only way you can get 11 is 1 times 11. Same thing for 13, 1 times 13. And 23, 1 times 23. There's no other factors like we had for 6. We had a 2 times a 3 that would give me 6, besides 1 times itself. Now a composite number, again, is a number greater than 1 with more than two factors. And again, these are whole numbers again. So 6, we already explained that one. For 10, it'd be 1 times 10 and 2 times 5 would give me 10. And for 18, we would have 1 times 18 and also 2 times 9 and also 3 times 6. So that is a composite number. Neither prime nor composite would be a 1. It only has one factor, 1 times itself, because 1 times 1, it gives you just one factor, which is 1. 0 has an infinite number of factors because 0 times any number is 0. Okay, so neither one of these would be prime or composite. So let's look at solving some of these problems. Before we do that, we're going to look at the divisibility rules, and these will help you in trying to determine whether they are prime or composite. And I know we've talked about divisibility rules at the beginning of the year. So a little recap. It is divisible by 2 if the ones digit is divisible by 2, meaning that all even numbers can be divided by 2. For a 3, so a 3 it's divisible by 3 if the sum of the digits is divisible by 3. So if we have, for example, 26, if we were to add these numbers together, 2 plus 6, which equals 8, does 3 go into 8 equally? It does not, therefore it would be not divisible by 3. Okay, it is an even number, so then it would be divisible by 2. And then if the ones digit is a 0 or a 5, then it's divisible by 5. And if the ones digit is 0, then you can always divide 10 into that number as well. So let's look at a few of. So now it says tell whether each number is prime, composite, or neither. So let's go ahead and do that. So go ahead and hit pause and answer these 3 questions. Well, number 12, since it has more than just 1 times 12, it also has 2 times 6 and 3 times 4, and because of that, therefore it is composite. The number 19, the only numbers that you have for that are 1 times itself. There are no other factors that work for that, therefore it is prime. And letter C, 51. That one, since it is 1 times 51, but there's also 3 times 17. That's a tough one. 3 times 17 works. 3 goes into it because if we add these two numbers together, 5 plus 1, which is 6, 3 goes into it. So therefore, it is composite. That one's a tough one. You have to be very careful. That's where divisibility rules really help and come into play. So now let's look at the next one. This is prime factorization, the good old factor tree. And what I want to make certain of is that you do it in this manner. This will help you stay very, very organized and not get so confused and bring down more numbers than needed. So you always start with the number 12, which is this one right here, and you give me any factors of 12. You can use 2 times 6, you could use 3 times 4. The only ones that would not work are 1 times itself. So 3 times 4, and any of those number prime, if they are, you circle them, and 3 is prime. Then you break down the 4, which was 2 times 2, and both of those numbers, 2's, are prime, so you circle them. Now, all the numbers that are circled, which would be 2 times 2 times 3, you put them in order from least to greatest, and then you can also write them using exponents, and that's why it says or and then a question mark. Well, to write that as an exponent, it would be the base is 2, and then since there's 2 2's, 2 would be my exponent times the 3. So either way, you can write those. Okay, and I know this is some review. Many of you had some teachers possibly tell you to bring down the next number so that they're all lined up along the bottom. I would recommend that you do not do that because many times students forget to bring them down or they bring too many down. So circle it and it makes it a little cleaner look and easier to read when you're finished. So go ahead and do the prime factorization for each of these numbers. Go ahead and hit pause and solve those. So for 36, we can use 6 times 6, or you might have used 4 times 9. Either one of those works perfectly well. You might have also used 3 times 12. I'm using 6 times 6, and both of those are composite, so 2 times 3. Both of those are prime. Then we'll break down our 6, which is 2 times 3 again. Both numbers are prime. So now I have 2 times 2 times 3 times 3, and if you want to write that as an exponent, 2 to the second power times, and since the base is 3 and there's 2 of them, then we would have to the second power for that as well. So 2 to the second power times 3 to the second power, or what I have listed here. For letter B, can you break this down any further? No, the only ones that you'd have would be 1 times 19. Therefore, you just simply write the number or the word prime, and you're finished. Again, if you have any questions, please take note of that and write those down, and we'll discuss it tomorrow. I'm going to let you go ahead and hit pause and solve for the number 18. So this one we're going to break down by I'm going to use 2 times 9. You might have used 6 times 3. That works as well. 2 is prime, so we're going to now say 3 times 3 gives me 9, and those are both prime. So my answer to this would be 2 times 3 times 3, or you might have had 2 times, and then there are 2 3's to the second power. Okay, let's look at our next one. It says factor each algebraic expression. Okay, and we're trying to do our prime factorization. Okay, so what you would look at here is we're breaking this down. So we're going to take my 18 and do the prime factorization of that. And so this would then become 2 times 9. This is prime. So then we're going to break the 9 down to a 3 times 3. And both of those are prime. So we end up with 2 times 3 times 3. But we can't forget about the variables. And x and y simply mean that there's one x and that there's one y. Now obviously, as I look at this, and I'm using multiplication signs, it probably in this situation would be much easier and to read and to interpret, and the reasons why they came up with a different sign with using our dot is so that we do not get our multiplication signs confused as x's. Okay, so this is why I would certainly recommend that when you are using a multiplication sign when there's variables, try to remember to use the dot so that this is not more confusing. Because if someone to look at this, it'd be very easily to think that this was an x, another x, and another x. Okay, 3 x's. So again, this is just saying that there's one x. This says there's one y. If there was an exponent on them, for example, a 2 on the y, then it would be times another y, because that means that there's 2 of them. But there is not for this situation. Okay, so this is your answer right here, and I would you can put this as an exponent. I think on these they recommend that you just list them all out. Go ahead and hit pause and solve this problem. So for the number 16, we're going to break this down, and you can use 4 times 4, or you could use 2 times 8. Either one of those works perfectly fine. They are both composite, so it's going to be 2 times 2, and then 2 times 2 again. So we have all these 2's, and they're all prime. So we're going to list them. 2 times 2 times 2 times 2 times, we have 1x, and since this says y to the second power, then it would be times y times 1 more y. Okay, that is doing the factors of an expression. Okay, so if you have any questions, again, please write them down. We'll discuss them further tomorrow. Hope you have a great evening, and we'll see you tomorrow.